Here is the Rotator MK1 build, which we will be modifying in a bit. Here is the previous Rotator MK1, and it works. And this version comprises of this 0.6 RPM motors with similar kind of structure. This is the L298 driver, and this is the AVR, and here is the sensor, and it is quite stable, currently running off of the 15-volt supply and connected with the serial COM port interface with the computer. And here we can monitor the system. Right now it is sitting at 00 azimuth and elevation, and let's try to put some command into it. Let's say we want to put the 25-degree azimuth and 30-degree elevation. So let's see, and when I press enter, and it will follow up to this mark, and here you can see the targeted value 25 and 30, and here is the actual position. So the error is 0. It is quite stable, and for some weight I have used this long wood as a boom, and the frequency that you can hear in the rotator while it is rotating. Let's put this on the 0 position. So if I enter, you can hear some noise, high frequency noise. Those are the PWM dead time. That is how it is being, the motors is being controlled. So there is no PID loop is being written. Here is only the dead time, and that dead time is depends upon the error. So as the error decreases, the PWM dead time will decrease, and the frequency happens to be some audible 1 to 3 kilohertz range. So here is the alpha value, in my case alpha sensor values, and the gain values that is worked for the 0.6 RPM motors with the similar Rotator MK1 setup. So it is quite stable. Let's try to put the 90-degree azimuth and elevation. So let's put this and let's see. So it will draw at 14 volt like 0.12 ampere, and right now you can see 90 degree elevation. I can see the rotator, and so yeah, it draws quite a lot less than this previous one, but previous one has more higher RPM motors, so the actuation of this is quite fast. But this one is the lower RPM motor, has less RPM, that is why it is quite stable. And the the motor has the worm gear setup, so there is less possibility to rotate itself, so it is quite stable and motor can rotate freely. Occasional some noise you can hear, that is the some deviation that may cause the motor to oscillate, so that is why you have to control this alpha value to get it as stable as possible. In my case, you can add a quite heavy thing, and it will just it will take all the things. That is how we have tuned in this one. So yeah, let's try to put it in the 0 home position. So let's see, and it has another thing, that is the motor wind up. So you can count how many wind ups it has done. It also has the software motor anti wind up feature. So as the motor rotates, and it actually calculates, if it's complete the 360, it will rotate around and start from the home position, it will then track. So it has that feature, so you have to, there is no all built-in software, no hardware interrupt. So we will try to put the hardware interrupt, as well as we are going to interface. Right now it is being interfaced with this USB serial communication, and we are thinking to upgrade this with the RS485, and with a small little display unit and the rotary encoder. We will make a small little base station, and there we manually, as well as we can interface the base station with the computer, and then control the rotator as in the home position, and the rotator may go at the top of our house, and obviously make the rotator more weather friendly, so that it can withstand the weather. So that is the Rotator MK1 similar setup, and we are going to modify it.